Hello, everybody. Hi. Oh, it's awesome to be here in Helsinki. Hey, Olen onnellinen, or something like that. So, I'm Christian from Thinktecture. I'm German, and I'm sorry about that. And we will talk a little bit about a thing and a topic that seems a little bit neglected in the Azure world. So, let's talk a little bit about stateful architectures. And the official title is, What? Life without databases? You really want to take away our beloved databases? Stateful architectures with Azure. So, if you want to get in touch with me after the session, either do so publicly on Twitter. So if you liked the session, send a tweet. If you didn't like it, send an email. Okay? So that's actually how it works. So either at Christian Weyer or christian.weyer@thinktecture.com if you have any questions about the architectural stuff, about the demos, about life, about Germany, about football, about everything that I may be talking about today and tomorrow. All right, so we have quite some things to cover. What is this state thing? What is stateless? What is stateful? Then we will take a look at two possible applications and two possible solutions inside of Azure. So the first one is being done and being implemented with the Azure Service Fabric, and the other one with Azure Durable Functions. Of course, everybody loves databases, right? Who does love his or her database? Show hands. Of course. SQL Server. Yes, come on. SQL Server is awesome, right? Oracle, no. DB2, no. MySQL, of course, MySQL is great. PostgreSQL, yes, cool. And of course, the new kid on the block, Cosmos DB. Ladies and gentlemen, Cosmos DB is awesome. It's still a little bit expensive, but I'm sure they will fix that. And then, of course, there is this one database that each and everybody in this room and online should know about. It's called Superbase. Who knows Superbase? Only one? Really? People, Superbase. Really? You don't know Superbase? So, I show you Superbase. So Superbase was built in 1983, and it, for sure, oh no, it's not there. So let's mount it. So let's load it again. And it was for sure the first NoSQL database on the planet. Let's switch on hyper mode, because then it loads a little bit faster. And that's it, right? That's our beloved Superbase. We can insert the data disk because we had to switch disks back then. We take the data disk and we just say return, and here we go. That's it. NoSQL at its best, worldwide available, endless storage on floppy disks. That was it. No cloud. Who needs the cloud in the first place? I don't know, people. Really, I don't know. Okay. Of course, everybody loves the database, but what is this thing that shows up in one or the other area of Azure, in the Azure documentations, when they talk about stateful architectures? What are those databases actually for today? I'm not talking about how you can build high-performance gaming solutions in Azure. I'm not talking about how you can build a, let's call it, a cloud service that you want to offer to others. What I'm talking about and what I'm targeting in my daily business life is ISVs and enterprises who want to build business solutions, business applications, business software. So this is the target audience of this session That means you want to build your business logic, your functional microservices, you want to provide integration solutions, maybe you want to build a software as a service application and solution on top of Azure. So this is what I'm talking about. What is it with these stateless architectures? So in my eyes, it actually doesn't exist. So it's a myth. There is no such thing as stateless architectures. Why? Because what is state? State is data. And we always have to deal with data, right? So either the data is in the database, or in the databases, or in the data stores, or the state is somewhere in memory on the server, or the state is in the client or on the client side. So we always have to deal with state. So stateless, when we talk about stateless, if the experts talk about stateless, what they are actually referring to is that we do not want to have, in a certain amount of time, to have to rely on the state being pinned to a certain node, right? To a certain, for example, server node, to a certain instance of a server, to a certain location in memory. That means stateless. Because what we do today with our databases is we are putting the state into the database, which means we have different kind of data and different kind of states. So one is the persistent state. That's our business state. That's the data from our business logic, from our services, from our microservices. That's the state what makes our applications tick. And then there's transient state. The state that we actually do not have to rely on once that we work with it, which is usually being done in memory. It's used for calculations and other stuff. And when we're done with it, we can get rid of it. But then there are situations where we need to still stick onto the transient state. For example, if we need to remember state, if we want to transition from one state to the other one. So we have the transient state and we have the persistent state. And of course we have several options and several shapes of data stores. So of course our beloved relational databases. We have NoSQL databases like document stores, like graph databases, like simple key-value pairs. And we have all those offerings and all those instances of database systems also inside of Azure, right? So we have Azure Table Storage, we have SQL database, we have Cosmos DB, and of course all those other non-native, non-platform as a service offerings that you can also host inside of Azure. But in the end, what is the important part is that we really need to persist our business data, so the real data, the data that our business logic is dealing with. Because based on that, we are able to do a lot of things like analyze the data, like doing reports and reporting. And reports is a very, very, very important feature for business applications, right? You need to get some insights into your data. You need to get some insights into what is good, what is not good, how to evolve, how to change things. So the persistent business data as the real data. And the real data comes from the processing inside of our application logic. And application logic nowadays is built as microservices, right? And yes, I know, if you ask 10 experts for a definition of microservice, you will get 15 answers, right? It's essentially the same as with service-oriented architectures the other day. If you ask for that, holy crap. So let's try to do a soft definition of microservices from my side. So of course, micro does not mean it must not be longer than 20 lines of code. Of course, it has to be small as in focused around a certain business domain. It has to be, so that's the single responsibility part. It has to provide autonomy. That means if you are doing microservices 100% right, you don't have a shared database, or you don't have a shared data layer, right? That means you have exclusive state. And exclusive state can be a really, really big pain in the neck. Because if you do that right, you really have to think about how to exchange data, how to sync data, who is the master data store, and so on and so forth. So doing exclusive state really, really right is maybe the hardest part of microservices architectures. Then, of course, they need to be isolated. That means they need to be isolated, but still we need to talk to them. They need to talk to other microservices. That means we need to have a technology agnostic but well-defined API. An API does not have to be an HTTP, HTTPS, web, REST, whatever you call it today, API. It also could be just a file share. It also could be just a message queue, right? So, but it has to be a well-defined entry point, inbound and outbound. Mobility means that it's not just for mobile applications. No, mobility means that I can be able to move the service around, and I just have to specify another endpoint for the well-defined interfaces for the other microservices or consumers to actually talk to that service. So mobility means running it locally, running it on premises in my data center, moving it up to the cloud, having it in Azure today and having it in Amazon tomorrow. Boo. But yes, you get the point. And at the end, in order to really, really make the microservices mesh work correctly, we need to communicate between those microservices. And then often we want to have an asynchronous communication, a decoupled one, so that we actually can keep up with the autonomy and with the isolation. And the exclusivity of the state and the decoupled message passing for async communication, those are maybe the biggest challenges of microservices architectures. Okay, so when we talk about architectures, when we talk about microservice architectures, what does it then mean to have a stateful architecture? So for me, this is actually two phases. That's two different points. So the first one is keeping state data nearby where I actually need it and where I have to work on it. For example, in memory. That's one aspect of stateful architectures. Another aspect of stateful architectures is to enable more complex stateful processes, like stateful orchestrations. Because no business applications that I have seen in the past, let me think, 21 years. So I had the 20th anniversary last year. So no business application in the past 21 years was so simple that you do not need any kind of complex scenario orchestration, long-runningness beyond just doing CRUD. So those are the two possible meanings of stateful. For number one, we are not saving our persistent state to a database. That's the conclusion. We're not putting the data into SQL, we're not putting it into Cosmos DB. We actually try to achieve a lower latency and try to achieve a higher performance through that. For example, by having it in memory or by optionally dumping it to a local disk. That sounds weird, right? That sounds like Commodore C64 1983 Super Base. But at the end, it all depends on what you want to achieve. And if you want to achieve lower latency and higher performance, this may be a valid measure to take. But of course, new questions are arising. So what about scalability? How do I actually manage scalability if I pin state to a node now? If I pin it to memory? What about availability? What if that node actually dies? What about my data? So these are the questions that need to be addressed and that need to be answered by a solution that provides us with a solution for stateful architectures. Number 2 is a totally different thing, a totally different beast. Number 2 says we want to enable stateful orchestrations. That means we want to be able to realize more complex scenarios. And, for example, we want to have long-running tasks, maybe like long-running workflows where human beings are involved. Then again, questions are arising. So what about the ease of the implementation? So how can I actually implement this? We have seen things like Windows Workflow Foundation. Who remembers? Oh gosh. We have seen things like BizTalk server. Well, anyway, I know a lot of people in here love BizTalk server. I will not comment about that. But what is the right abstraction layer? So BizTalk, for a lot of use cases, is just too much. Well, not only money-wise, but it's just too much, right? It's the wrong abstraction. Windows Workflow Foundation also was the wrong abstraction for a lot of scenarios. So we have logic apps, right? Logic apps looks cool in the first place, but each and every time I'm using logic apps, I ask myself, who is the target audience? Who is the target audience? Is it really the technical architect? I don't think so. Is it the developer? I don't think so. Is it the business developer? I don't think so. So if you know the answer of who is the actual really valid target audience for logic apps, let me know after the session. Thank you. So we're looking for the right abstraction, right? Stateful services are for higher scalability, for higher performance, and for higher availability. And look at the first 2 points. Usually when we are talking about distributed application architectures, we try to focus on one. We try to optimize one, and the other one, well, is losing. So if we try to actually make the performance higher, we might get into trouble with scalability. If we want to make it more scalable, we might get into trouble with performance. Or what we hopefully can achieve is to have both at a very, very high level. And of course, when we're talking about cloud-based architectures, when we're talking about business solutions, business software running in the cloud, we want to be able to provide a very, very high degree of availability. So there is a very interesting article, and I urge you to read it maybe tonight, after the first beer, or maybe before the first beer. It's about how to eliminate the database for higher availability from the American Express IT department. It has some very, very interesting insights, and a lot of those thoughts and approaches we can see and implement in Azure quite easily. For number 2, it's about the stateful orchestrations to realize all those complex scenarios, but we don't want to explicitly have to deal with that persistent and that transient state, right? We don't want to have to think about, okay, now I am in that state, I need to persist that to the database, then I have to create a timeout for, I don't know, 10 minutes, and within that 10 minutes, I'm waiting for an event from the outside, and when it's not coming in 10 minutes, I have to cancel, and so on and so forth. So there is a lot of complex stuff going on. We don't want the burden of dealing with this state. At the end, we as developers, what do we actually want? We just want to write code, right? So usually, we want to write code. There are 2 solutions on the horizon. For number 1, there's one solution, and for number 2, there is another solution. So in order to have the stateful services, the stateful in-memory services, we can have a look at Azure Service Fabric. Azure Service Fabric is a beast. It's a monster. On all ends. I call it a low-level infrastructure as a service towards platform as a service offering. Because that's kind of how it is, right? It's not just IaaS, but it's not yet really PaaS, and of course it's not serverless. But it's the underlying technology, the underlying platform for a lot of services that Microsoft is building and has been building. So I like to think about it. WCF in the days was called .NET on steroids. I call Service Fabric WCF on steroids. Right? And if you look at it from the outside, I think half of the WCF team is on the Service Fabric team. Hello, Mark. So the mental model that I like to use for Service Fabric is it's a cloud operating system, period. It's a quite low level that you really, really have to grok. You really, really need to know your guts here. You really, really need to know how it is working. So it's more like infrastructure as a service. They provide us with a very, very thorough and a very mature platform and runtime, but for maybe 80 to 90% of the customers that I'm talking about, for the ISVs and the enterprises, it just may be too low level. But still, it has some awesome features like clustering. You get a cluster and you have primary nodes and you have replicas. You get reliability, availability in it. And of course, you have those service features, those microservice features. And if you look at presentations about Service Fabric, if you have a look in the documentation, in the official Microsoft documentation about Service Fabric, when they talk about microservices, they think a little bit different than I did just a few minutes ago. But we have the ability to build stateless services and stateful services. So services that keep data in memory. And now flashback to 2000. Who was in the business already in 2000? Quite a few. Okay. So there was a feature called Com+. Before that, it was Microsoft Transaction Server, MTS. That was the day, or that were the days of, of Windows 2000. And I wrote an article in German in 2000 for Computerwoche, which is not the most technical publication, but it was fun to write. And back then, Microsoft was announcing new features for Com+, like distributed transactions. What an awesome idea! Hashtag not. At least for the internet times, right? So inside of the enterprise with DTC and two-phase commit, things may have worked, but once you started to hop across boundaries, things did no longer work. And in that article, I wrote about a feature which was there in the beta bits, and it was called IMDb. Now, it's not the movie database, it's the in-memory database. Who remembers that feature? Only 3. So, of course, Magnus, you remember everything because you know everything. Yeah, okay, maybe. So IMDb was one of those ideas to have a tool in your hand to build stateful architectures in Com+. And if you like, yes, with Visual Basic. Or in C++, based on COM, ATL, you chose. But this feature never made it. Fortunately, unfortunately, I don't know. If you look today, what we have in Service Fabric is exactly a feature where we can build stateful architectures and stateful services. So when I'm now talking about Service Fabric, I'm not talking about Service Fabric with the big picture, I'm only focusing on those stateful features, okay? Because Service Fabric is much more, and it's a valid approach for a lot of solutions, but maybe not for the 80 or 90% of the ISVs and enterprises. So we have essentially two options. When we are building microservices with Service Fabric, we are bound to the runtime and to the API they offer. That's okay, and that's nice. But we are completely agnostic to how we communicate between those services. And there is one very nice feature, and this is called, and I'm not kidding, it's called remoting. It's back. Remoting is back. So it's no longer system runtime remoting, but now it's Microsoft Service Fabric services remoting. Welcome to the 90s. So service remoting is back. It's RPC all the way along. If you want to do that, enjoy it. There is a version 1 and there is a version 2 in the meantime. Of course, they are incompatible. Have fun upgrading. But if you want to do stateless services, that's just there, just as you know it, more or less. You can then provide your web API facade on top of that, and you're good to go. If we want to have stateful services, well, they call that reliable services, and reliable services are working based on reliable collections, or to be more specific, reliable collections and queues. And that's a really freaking cool feature. It's a collection and a queue based on the .NET collection and queue. It looks like a queue and a collection. It smells like a collection. It talks like a collection, but it's different, right? So it's replicated, it's asynchronous, it's transactional, and it can be persisted. So we are working on our data in memory, and all those features are provided to us by the Service Fabric runtime. So if we have a look at some code, so here we have a very simple Hello World-ish stateful service. That stateful service needs to be bootstrapped. So here, based on .NET Core and the dependency injection and web host builder. And then in the end, what we have is a stateful web API. And we don't need a database. Actually, we don't have a database. Actually, you should not use a database here because this is an explicit design and architectural decision step to use those collections. Those collections are working together with a reliable state manager. And then you have to write code like this. And you know, it looks a little bit like database programming, but in memory. And that's it essentially, right? You just have to convince your brain that this is still good, and we have to use transactions, but that we don't have a database backed behind that code. It's all in memory. Well, this is nice, but as I told you, those are not the collections and the queues that we love and that we got to know for so many years. They are actually quite different in behavior. So if you just add state to that collection, that state is not persisted yet. You have to explicitly call a method on that so that the runtime can talk to all the instances, all the nodes, all the replicas in order to provide the transactionality of the right action. So beware. It looks great, it looks awesome, but you really need to know your stuff here. There is a second option. The second option is called reliable actors. there is quite a well-known pattern called the actor pattern or the virtual actor pattern, and it's really age-old. It's from the 70s, I guess. And the virtual actor, at the end of the day, is an isolated, independent unit of compute and state with single-threaded execution. Does anybody remember the WCF singletons? Single-threaded, non-reentrant? So yeah, virtual actors can really make developers' life easier, because if you look at the programming model is quite slick. So the programming model at the end is you derive from an actor class, you use the state manager again to get your state or to add state to the state manager. And in order to decide what level of persistence you want to have, you just use, you just use an attribute. So you can have no persistence, you can have volatile persistence, which means it's just in memory, or you can have a persistence, which means it's being written to disk and through the Azure Service Fabric runtime to all the nodes involved. So still, I think you can build quite interesting solutions with that, but if you have ever had to deal with Service Fabric, how to set it up, how to get it running, how to scale it, how to secure it, how to do the design of all the nodes, how to actually slice it, it's really, really a lot of work. And I personally do not think that we as software architects and software developers and the companies that we are either consulting or the companies that we are working for should actually advise on IaaS, on infrastructure as a service level solutions in 2018. That's actually wrong in my eyes. Of course, we will need Service Fabric. Microsoft needs Service Fabric. Microsoft loves Service Fabric because they will build their first level services on top of that. But for us, usually, I guess it's not the right target. So if we want to talk about solutions for number 2, the orchestrations, let's have a look at Azure Durable Functions. So Azure Durable Functions is part of Azure Functions. And Azure Functions is a small piece of a serverless approach. And you heard it here first, serverless is the future, period. So on the client side, progressive web apps is the future. On the server, in the cloud, serverless is the future. So to summarize, it's app store-less and serverless. We no longer need app stores. Nobody wants app stores. Nobody wants servers. Welcome to the brave new world. And Azure Functions is just a small, small piece in the mosaic. We have a lot more to offer, like awesome Cosmos DB, like mind-shattering event grid. And I think you will hear about it later on, but I'm not sure. And there are a lot more pieces that actually paint the picture of serverless. And functions is one, and a certain extension of Azure Functions is durable functions. So what durable functions allows you is to abstract away the management of state for complex stateful orchestrations, and we can just write code. The interesting part is that we are modeling, we are able to model a state machine, and that state machine is being exposed as an HTTP API. So we can talk to the state machine via a REST-ish way. My mental model for that is serverless orchestrations. So it's a completely different level of abstraction here compared to Service Fabric. What's really interesting and cute is that this is not really new. Although durable functions are still in preview, there is a framework which is called Durable Task Framework, which is around since a couple of years, which is the actual mental successor of Workflow Foundation, I guess. So let's call it Workflow Foundation done better. It's a really nice programming model with async and await. If you look at it tonight, after the first beer, or maybe before the first beer, go to the GitHub page, clone it, have a look at the samples. It's really, really nice runtime for durable tasks. So durable functions, they look really, really interesting because you can realize very, very cool and complex things by just writing code. You don't need any XML, you don't need any JSON, schemas, yada, yada. You just write your .NET code. But you have to play by the rules because there are rules. As with any abstraction, especially with any abstraction that has to deal with long-runningness, you have to play by the rules. There are two types of functions. One is called the orchestrator function, and the other one are activity functions. Rings a bell? Activities? Windows Workflow Foundation? No. So the orchestrator is the entry point. The orchestrator allows you to define your workflow, just in code. It allows you to call other functions, either synchronously or async. The interesting thing is, you can get back the result of those function calls and store it in variables, and those variables are automatically being persisted for you. So you don't have to deal with the database stuff. You don't have to use T-SQL. You don't have to use Additive Framework for managing all that stuff. It's being done for you behind the scenes. The orchestrator can also allow output from, can also allow checkpointing. So that means wherever you use async and await, whenever you use await, the runtime is automatically checkpointing the progress. The local state is never lost because it's being persisted. And the second shape of functions that are being called from the orchestrator. So the orchestrator has to be stateless, right? Obviously, it has to be short-lived. It has to be free from any kind of I/O operations. It's just the initiator, the orchestrator, the conductor, if you want. And then there are those worker functions, which are called the activity functions. So an orchestrator can call activity functions, sub-orchestrations, or wait for external events. If we look at the patterns that we can implement, some look quite familiar. So for example, the stateful singleton, it looks a little bit like an actor, but it's different. So there is no implementation of actor pattern for durable functions or in durable functions. What we usually want to implement with long-running tasks as long-running workflows is a scenario with human interaction. Okay, so let's take an example. Let's think about we have a small sample. That sample is maybe a system for home automation. So I want to, and that is a real, well, it's a sample, but it's based on a real proof of concept we did for a customer. So I want to be able to have a look at my house, at my living room, at my kitchen, you name it. And that's just a simple web application. And we can have building information, we can have information about blinds and shades, we can have information about climate data, so we can control to turn on the collection of climate data, turn it off, and actually have a look at the data, and we can have push communication if a certain degree of temperature, for example, has occurred. I want to be notified about that. Okay? So first, we have to log in, and I'm not sure you will guess that password. So the login was done with identity server, by the way. The data comes from Cosmos DB. In front of Cosmos DB, there is an Azure function activated by HTTP, so it's all serverless. I call it serverless IoT. It's completely serverless. And what I now want to do is I want to be able to register for text messages. So that means I need to provide my mobile phone number, and my mobile phone number, let's switch over here, and let's go to here, and let's go to here. So my mobile phone number needs to be verified, okay? How could that look in code? So here is the solution for the serverless IoT sample, and we have two functions, one for orchestration start, being triggered by HTTP, and another one for the actual phone verification. So the HTTP orchestration start is just that. We have an HTTP trigger, which gets data via post. We are doing the authentication inside of the function because we are using a JOT token, which is a bearer-based authentication approach, right? And we are talking to identity server to validate the token. And then we are able to dive into what we actually want to achieve. So this guy does really nothing else than just redirect to the actual function that we want to call. And the actual beef is happening over here. We have a function for SMS phone verification, and it has an orchestration trigger. That orchestration trigger, now that's the orchestrator function, right? So this is initiating a new orchestration, a new workflow. And in there, we are using that durable orchestration context. We have a timeout of 90 seconds. We are retrying 3 times before we are going to fail. And what we are going to do is we are calling a function that's named sendSMSChallenge. And after that's done, we are waiting for an external event which is called SMS challenge response. And that's the programming model. There is nothing more to it, but you can see we have certain constraints on the programming model, on the API. That's what I mean when I say we have to play by the rules. Okay. And if we are done, the number is authorized. We got back the code that we sent out, and we can add that phone number that we just have verified to our database, to our user profile, whatever you name it. So if we are going to demo that, yes, I know. Let's go here. Let's send that over. We can see we send it to the SMS phone verification. I just got a text message via Twilio. It says 2485. 2485. We're sending it back, and we're done. It's calling the SMS challenge response. We have talked to that state machine that's being implemented with durable function via HTTPS. So it's just a RESTful or a REST-ish approach to communicate with that state machine. That state machine is completely written and implemented in C#, in .NET. And by the way, C# is currently the only language that's supported. During preview, maybe, hopefully. Maybe they will support Visual Basic later on, I don't know. But maybe F# as well. And that's one of those use cases where durable functions actually can shine. If you have to implement long-running tasks, long-running orchestrations, long-running workflows with human interactions, where you maybe earlier had to resort to a lot of custom code and build your own solutions and frameworks, or maybe you resorted to some kind of workflow runtime and engine. Now one option is durable functions. Of course, not everything that glistens is gold. There is good, there is the bad, and there is the ugly part. And there are a lot of scenarios and a lot of areas to talk about. And of course, a consultant's answer is always, I'm sorry, but this depends. And it really depends. It depends on your project, it depends on your customer, it depends on your team, it depends on your use cases. So one take from my side is, I really think, and I'm not sure you have heard it already, but I think serverless is the future. I'm not believing into IaaS too much. Service Fabric, of course, is much more mature than Azure Functions, and especially Azure Durable Functions. Service Fabric has a completely different set of target use cases in my eyes. So stateful architectures is just one nice feature that you can or cannot use, but it has a completely different audience. And that audience also includes people who want to migrate existing applications into the cloud, into a scalable, reliable environment. So migrating applications is an explicit feature in Service Fabric, and it's not actually on the table for functions and durable functions. Both approaches are cross-platform, cross-location. That means you can use containers, you can use Docker, you can use anything, but still both have their own runtimes, which you need to deal with, which you need to learn, the APIs, the constraints, etc. The programming models, Service Fabric, as I told you, is WCF on steroids, so it's very object-oriented, it's very RPC-ish. Functions is functions. So functions is functions and events. And that's a completely different way of thinking and of implementing. Reporting, I told at the beginning that reporting is a very important feature for any business application. And how do you do reporting with stateful services in Service Fabric? You don't. Because you don't have any explicit way to handle the data. You have to write code and a solution that actually persists that data, which is in the stateful collections, into your database so that you are able to do reports on the database. And that may be a lot of work to do. Pricing. I tell you, we did a proof of concept for a customer early on, and Service Fabric can be really expensive. Just provision a cluster, just do the Hello World style in Azure, and it will be really expensive. So the pricing model and the way of thinking in how we use resources, how we use memory, how we use time with a serverless approach is a completely different beast and fits the bill much better for a lot of ISVs and enterprises that I have met. And last but not least, some people want enterprise-grade software at the speed of startups. And that does not work with IaaS. That may work with certain offerings of PaaS. And it quite surely works with serverless. And I'm not sure you already heard it. I think serverless is the future. So, databases no longer? No, of course not. Stateful architectures are a very interesting piece of architectural wizardry that you may need or may not need. If you want to optimize low latency, if you want to optimize performance, maybe you can have a look at what Service Fabric offers, but that means that you have to use Service Fabric in the first place, and I'm still not convinced that Service Fabric is the right level of abstraction for maybe everybody in this room here. If you need to implement long-runningness, like orchestrations and workflows, then durable functions is a really cool way, but it's also a very dangerous way because it implies certain semantics in the programming model and in the behavior that you as a .NET developer may not be aware of. So really, really learn how the API works, learn how the runtime works, and learn to embrace all those features, and those may not be compatible with what you have been doing in the past years. And in the end, of course, it all depends. And that leads me to thank you, everybody.